If I understand what you have in mind with the virtual machine, it's basically a way of having it come back up elsewhere and have the same network identity, so you don't have to explicitly acknowledge that, but you're going to have to checkpoint that virtual machine to disk, or it won't survive the failure, or some non-volatile storage, it won't survive the failure of the node. And then you're backing yourself into the corner where your MPI has to be able to resume at some arbitrary point, because we're now talking system checkpointing. Maybe I'm being too pessimistic. I think that the user checkpointing is likely to remain a more viable option, at least for several years. And so I think what I'm most interested in is a scheme for doing this fast checkpointing and then recovering onto alternate nodes, and not actually having the hardware I'm using for the checkpointing increase the error rate so much that it's a net loss.
I think that you're definitely right on track, right? So virtual machines, I mean, that's why a lot of people haven't implemented them in HPC right now, because they really don't fit the problem that they're meant to solve in other markets, right? But it's certainly coming along, and probably what you said is correct, right? 2 to 3 years out, virtual machines probably will have a bigger place within HPC. And as far as the ability to do what you were talking about, right, the quicker checkpointing, come see us. We've got some pretty cool ideas about how to do that in the not too distant future.
I have a question about queuing system. And we are using PPS. For some reason, it's frequently oversubscribed and driving user crazy. Yes. I mean, is it, do other people see this kind of problem, or the queuing system that we recall, and sometimes they will assign like more than 8 jobs there, and of course everybody's the job. It depends if it's a multiple nodes job. One job get run one over another, and everybody's slowed down.
Well, I would encourage you to use Grid Engine, because I was one of the developers on it. But the challenge, I guess, the challenge with queuing systems is figuring out, what are all the configurable options that you have, and making sure that you capture all your policies into those configurable options, and then come up with a realistic configuration that your users can live with. So you start getting into some of those more complex problems, and it tends to push you in the direction of using more complex policies. And I know we had developed a lot of policies for sharing, and then you get into resource reservation, and often you're kind of driven to start implementing resource reservation and backfilling. And there's quite a few queuing systems out there now. I would say most queuing systems will implement those types of capabilities to make the maximum use of your resources. So I'd encourage you to kind of go out and look at what are some of the queuing systems out there now, and what are some of those features that they support, and how hard is it to turn those features on and use them. We do recognize that's a real important part of using HPC systems, and that's one of the reasons that we integrate for our cluster management software at Appro. We integrate the job queuing system into the software, and we include it with every system we sell, because we realize some people are already tied to a particular queuing system, and that's fine, but we want our solutions to have, we want to rely on the solution.
Thank you for coming, and if you have more questions or you want to discuss more, you can go to Appro booth number 1200 or Mellanox booth 3001. Thank you again for coming.
That's right. Thank you.